have a website where people can actually.
Now we can see Karl, at least his avatar.
Yeah.
Hey, Karl.
Hey, how are you?
Hello.
Hi, good morning.
Good to see you. There is a the management of the Lowell school and the other your fellow panelist, Yong, Dr. Zhang.
Hello.
All right.
So Young, Karl, I know you might not know this, but Vladimir, what we do is we're going to record this session. So I'm not sure how many students are going to actually be in the session today. A lot of our students do work, so we try to have this at a lunchtime, around lunchtime, to accommodate as many students as possible. I think when I looked at it last night, was it 17? I think it was 17 participants that registered. But again, I'm not sure how many is going to show. So we could just kind of keep the conversation flowing, knowing that we're going to also push out the recording to students at a later date. Okay?
Great.
Yeah, sounds good.
And the distribution list is what? Several hundreds of students, Arlene?
We have over 900 in the Lowell Institute School. I was just looking at how many are actually analytics concentrators, and I can get that number for you.
Well, analytics will be a fraction of that, but are you sharing just for the analytics or for the entire school?
No,
For the entire school.
Yeah, the Lowell Institute School.
Yeah, which is great because some other programs might be also interested, like information technology, business, some healthcare, as you know.
Yeah.
All right, so we are good to start in a moment.
Yeah. Thank you both for taking your lunch time and being here with us today.
Absolutely.
Happy to do it.
Kind of the goal of this Mentorship Matters series is really to increase student engagement. And so one, they get to see the faculty lead, but also have the faculty lead or program lead identify panelists who they will resonate with students. Oftentimes there might be a disconnect between what you're doing in the classroom to what industry leaders are saying, or alumni, or former students. So this Mentorship Matters is really meant to kind of connect the students to like industry leaders, as well as better connect with the program lead.
Mm-hmm. And Arlene, you're doing it for various programs once a year, right? Or once a semester?
Yeah. Once a year.
Once a year.
So
good
I'll
to
give
know.
it another couple of minutes, and then I'll go through and introduce the Lowell Institute School and our Mentorship Matters. I must say, I'm really looking forward to this discussion because analytics is such a huge part of healthcare, which is my domain. I always have so many of my students asking about analytics courses, and so I'm really happy to be here to learn more.
Absolutely. Have you started, Arlene?
Mary, should we start? Do you want to hit record?
I believe we actually already are recording, so you are welcome to launch whenever.
All right, great. Good afternoon. It's officially 12:01, so I can say good afternoon. My name is Dr. Earlene Avalon, and I'm a teaching professor here within the College of Professional Studies. I'm also the director of the Lowell Institute School. We want to thank you so much for taking your time to attend today's session. If you're not able to attend in person, please make sure you write down the names of our program lead and our panelists to ask them follow-up questions at a later date. The Lowell Institute School is part of Northeastern University's College of Professional Studies. We have more than 50 years of experience really aligning higher ed with professional aspirations. LIS, as we call it for short, provides students with scholarships and opportunities to increase their engagement here at the university and in the college. So there are numerous programs in the Lowell Institute School, which includes analytics, biological sciences, biotechnology, digital communications and media, healthcare administration, health science, information technology, mechatronics, project management, and psychology. So as you can see, there are many different disciplines within the Lowell Institute School. So if you're a student in one of those programs, you are in fact part of our Lowell Institute School family. Today's presentation on Mentorship Matters focuses on analytics, and I'm going to turn it over to my colleague, Dr. Vladimir Shapiro. Thank you.
Thank you, Arlene, for a nice opening. Yeah, so let me introduce two other panelists. Right in the middle, at least on my screen, is Dr. Rexer. And Dr. Rexer is a founder and a president of the Rexer Analytics. And he holds a PhD in experimental psychology from the University of Connecticut. And I imagine that during the discussion, Karl may find appropriate if whenever to speak about his company and his experience in the past. I'm not gonna be talking about that myself. And the second panelist would be Dr. Zhang, and he's a senior director of data science from Zazzle. And recently he started as a part-time lecturer with us with Northeastern University. Or maybe Karl one day will do that too. But yeah, please welcome the panelists. So one suggestion for the audience, whoever has joined us and will join during that in-person discussion. If you feel like submitting questions during the during the session through the chat channel, that would be helpful. So then we can ask the panelists right away. Or you can keep your questions till perhaps last 10 minutes or so when we will take them in person. So that's kind of how we were planning to run at this discussion. All right, should we get going, Arlene? Yeah, so let me start maybe with one relatively general question, and question comes from the fact that our audience are bachelor students in analytics for the most part, and the natural concern and a purpose of why students take their time and resources to study is to find their place in the job market. So how would you describe the future of data analytics and the job market? Maybe I don't know, who wants to start? Karl?
I can start. I can start and then throw it down to others as well. I think it's a huge job market, and I think that in all aspects of data analytics, whether it be data science or data engineering, data architect, other areas are all going to be really very highly in demand in the coming years.
Well,
Yeah.
that's...
I can continue. Totally agree with Karl. I think the field of data analytics is growing, but it is evolving rapidly with the rise of automation and AI. So I think some people are actually concerned about like the job displacement with AI, but I think I agree with Karl, like the growing demand for data-driven insights, decision making, or AI ML development, actually ensure that data-related jobs will still be in high demand. So some example, like we have very increased demand for data engineer, and for the analyst, if they can incorporate domain knowledge to derive insight and optimize the business. So that will be also in strong need. And one last thing is like we in most of the industry, we actually want like full stack or hybrid roles. I mean, if the person can do several things like data engineer, data analysis, and maybe also the modeling, so that will be in high demand, I would say.
Yeah, those are good points, and I think that the idea about evolving skills is an important one to make. So I definitely want to emphasize your point about that, because we've always, I think, over the decades had a need for continuous learning. It's not just while you're in college, but while you're in the job, you're definitely going to be learning new skills and applying those. But I think the pace of that has accelerated. So it's emphasized the need for continually learning new skills. So the types of programming skills that you might be learning in college now are great. Now, you might not be programming in exactly those tools, or exactly those programming languages 5-10 years from now. You might have to learn new programming languages, but learning how to program is important.
Yeah, thank you for bringing that all up. And you touched upon a couple of specific subjects, such as different roles within the data analytics realm, right? That's a big domain, and there are some, as you hinted, the data engineers and data analytics and data scientists and so far so forth, or data architects, which I want to devote some time, right now, to speak about distinctions between them, but they might not be that obvious to the audience. So it's an interesting subject on its own, as well as the generative AI or AI taking over some of the duties of that traditionally have been in the domain of data analytics. So we'll talk about it, very specifically, because I think each of those subjects is important. But I thought that probably it would be beneficial, to say a few words about our experience. Then it will add some more, should I say, credibility, or maybe a perspective to the audience, so to understand what background we are coming from, right? So I'll start with myself, and then Karl and Yong, you will jump in. So I started my career as a research scientist primarily in computer vision, but also pattern recognition and such. Then I moved to the industry and spent many years working for various industries, such as fintech and biomedical and heavy industries, energy transition, oil and gas, and so far so forth. And I started teaching about 5 years ago with Northeastern. And now I'm leading this program, and I'm sure the other panelists have probably as diverse as a career as mine. So let's maybe you will send a few words. Let's Yong, maybe you will start this time.
Yeah, thanks for that, Vladimir. So for my case, I got my PhD degree back in 2006. My major is computer science. I focus on data mining, machine learning stuff. So then I joined several companies, including Oracle, where I do some software development at the start, and then I start with the data analytics and machine learning work. So mainly focus on within data center, we try to forecast the failure or anomaly for some assets, including both hardware and software, actually. So then I joined like a couple companies related to e-commerce and retail. So some applications of AI ML in this area include like customer segmentation, inventory optimization, supply chain analytics. And for e-commerce only, we also do search ranking, recommendation, personalization. I also work on the marketing part, like, try to do some data engineering work to integrate with digital ads platform, like Google, Facebook, TikTok. And we also do the marketing measurement and optimization. By that, I mean, we actually build some like models, like try to understand the different contribution from different marketing channels to the revenue or profit. And also we try to, do the optimization part. Another big piece is actually that, is the digital transformation for traditional industries. I work in GE, where I met Vladimir, and then I also work at Hitachi. So basically, we work with customer in different industry like oil and gas, coal mining, electrical company, and also the amusement park. So, and for this traditional industry, I think they try to do the digital transformation, like, they try to leverage more of the data, and then they try to introduce the predictive capability and, for example, like anomaly prediction, failure prediction, and maybe sometime like some optimization work, especially for amusement park. Yeah, that's all.
Yeah. Well, as Dr. Yong points out, there's wide ability to apply data analytics to a very diverse set of fields, all the ones he was just mentioning. We also at Rexer Analytics apply applied statistics and data science to a wide set of industries. And that's some of the fun for us too. So it really goes from healthcare to technology companies, to banks, to services companies. Just all companies need to be able to think in a data-driven way and make data-driven decisions, and therefore they need analytics of different types. Whether they're trying to do new product development, whether they're trying to look at customer retention, it could be so many different things. So when we think about the specific skills that people need going into that, I think that there are a combination of some hard skills, like people really do need to know, some sort of programming. It doesn't matter so much what type of programming, but some sort of programming. They need to have good data skills. And by data skills, I mean the ability to go into databases, pull the data that you need, manipulate that data in ways, hone it down, transform it, use it, and then think about what the data means. I think people also need statistical skills, which I think is sometimes overlooked in some of the data science programs, that people want to immediately jump into machine learning and generative AI and all that stuff. But I think that some core statistical skills are often really needed. And that's like thinking about sample size and thinking about the power of your analysis or things like that. I've sometimes actually seriously come across a situation where someone showed me a pie chart and it had a nice 50-50 split. We looked further down into what was going on, and we realized that in that subsegment of the population, there were 2 people who answered some sort of survey, and that's why we had a 50-50 split. We don't want to make decisions based off of 2 people answering a survey. So thinking about sample size, thinking about your data is important no matter where you go. So I think that that's something that we need to sort of like make sure we don't lose sight of, thinking not about always the technology and always the programming, but the overarching things about what does your data mean and what data are you looking at?
Yeah, totally. I think I want to add one more thing. I think I work in several industry, but I think in general, I think data analytics is used across nearly every industry already. And I kind of feel analytics, like AI ML modeling are generic and flexible skills. So, but I think for people who just start with this area, I think if you can work in different industry, then you gain some experience that will make you adaptable to like various challenges and applications. So I think that's just one thing I want to add.
That's a great point. And someone in the chat was asking about mentorship. And I would say that some of the best teams that I've worked on are ones where I've been able to learn from other people who have different backgrounds. So I worked in a bank in the early 1990s. And some of the people that made up our data science or analytics team came from backgrounds of statistics or marketing, physics, engineering. And they all brought their own sort of perspective about thinking about data, but we were all very, very data driven. And that diversity of the team was wonderful. And so I would say that if you have the ability to seek out mentors or team members that you can learn from who have a different background than your own, that will help enrich your way of looking at data and help enrich your skills.
Yeah, thank you. So I wanted to, I mentioned that Dr. Exer hasn't, yet taught for us, but maybe one day he will. But he did present a number of guest lectures for us. And so I know a little about the company that he founded and actually the nature of the business. So there is a number of industries that you work with. Is it right, Dr. Exer?
Yeah, we do.
Can you name some of them? Mm-hmm.
Oh, sure. Yeah. And everybody's welcome to certainly check out our website and contact me directly as well. It's just rexeranalytics.com. But we do probably about 30 to 40% of our work is on survey research and marketing data that we go out and help our clients gather that data because the type of business questions that they have, they don't have data inside their databases on that. So this could be trying to do sort of like pricing studies. We're currently doing a pricing study for one of our clients. They have a retail product that they want to bring to market, and they want to know sort of what's the best optimal pricing that they should try for that. We have other clients. One of our biggest clients right now is OneBlood. They're the second largest blood bank in the U.S., located in the Southeast. And we're doing a variety of predictive models for them to help manage their donor database. So they have blood donors, and they have several million blood donors in their database, but they need to know who to contact at what frequency to get those donors motivated to come in to donate blood, whether that be whole blood or platelets or different types of other blood products that they need, because it's a very perishable product, that some of the products only last for a few days, and you have a constant flow of people coming in. So we need to help manage that with the right sort of marketing campaigns to target the right people. And that's been very successful. And those sort of targeting models are very similar to what one does when working with other companies. We work with HP and many banks to help build marketing models, say, what's the best product to cross-sell to these people, or what's the best time to communicate to them to get them to come in to buy something. Talking to donors, blood donors, is very similar to that. So it's seeing those sort of ways that the skills and techniques that we've done with customer acquisition and customer retention apply equally well to blood donor acquisition and blood donor retention. So those are some of the types of projects that we've been doing recently. But again, over the years, we've worked with so many different types of companies, and it's been our pleasure to do so.
Yeah, it's kind of amazing to see how certain problems, they kind of applicable to many different industries. It's really surprising. You would think the industries are so much different that you would face, but no, right? There are some common motives all over the place. So there was a question. Yes.
Yeah, Doctor, let me just emphasize that, because I think you're absolutely right, Dr. Shapiro, that no matter what industry you're in, whether it be even higher education, where we've done some modeling for like predicting which students are going to drop out. And those models are very predictive and very accurate to be able to identify which people are more at risk of leaving. That's very similar to identifying which blood donors are not likely to come in and donate, or which bank account customers are likely to close their accounts. So no matter what industry you're in, most industries want to acquire customers. They want to develop those customers to enrich the relationship and buy more stuff or get more involved. And they want to retain those customers. So it doesn't matter whether you are a bank or a local coffee shop. You always want to acquire, develop, and retain your customers. So the analytics of that is a lot of what we focused on. Now, there are many other sorts of things, and Dr. Yong has mentioned some of those, whether you're doing like some optimization or customer segmentation, or integration with some of the whether it be sort of like TikTok or Facebook or other sorts of data that might be different than our sort of CRM, customer relationship management. But there's so much data involved that companies have when they have customer bases and they know something about their customers that they can use to help make their products best aligned to the customer needs and help make the companies profitable.
Yes. Mm-hmm. Yeah, that's a great point, which kind of makes our skills that we acquire in the program convertible, so you can apply them in many different industries. But we're going to talk about that in more details a little later. So what I wanted us to touch upon, and there was a question on the chat channel about the skills, right? So what kind of technical and soft skills are needed in the field, and maybe if you can extrapolate for a couple of years ahead. As you said, I think Dr. Exer said that you might see different skills and tools in need in 10 years from now. But how about kind of short perspective, maybe a year from now or so, that we can be maybe more accurate with predicting that? So what do you think?
Yeah, I can start. Yeah, I can start. I think data analytics is a very big domain. I think depending on the specific roles within this domain, the key skills could be different. I would say, there could be like 3 major roles, like data engineer, data analyst, and data scientist. I think for data engineer, it is the foundation of the data analytics. And so any data analysis or machine learning model begins with the data. I think we need high quality data. We need enough data. So like in both quantity and quality perspective. So so to me, this is I think data engineer is a very solid role, and the key skills for this role include like data collection, ingestion, storage, ETL, data management, and usually we use like some tools related to database, data warehousing, SQL, ETL, Python for this purpose. And other skills could be related to like big data technology, such as Hadoop, Spark, and a lot of companies use cloud storage and computing, so such as AWS, Google Cloud, Microsoft Azure. So I think all these are skills for a good data engineer. I think the second role, data analyst, this can actually include like some other role like business analyst, product analyst, and maybe BI analyst. And the key skill for this role include like the EDA, exploratory data analysis through programming, such as SQL, Python, or R, and data visualization, dashboarding. For this, I think we usually use some tools like Tableau, Power BI, Looker Studio, Metabase. I think for data analysts, sometimes they also need to cover some statistical testing, like A/B testing, or causal impact analysis. I think for data analysts, one last thing but not the least is the domain knowledge part. Also, it's not required for the data analyst at the start, but I think usually we need to accumulate enough domain knowledge in order to derive like actionable insights to better optimize the business. And the last role is data scientist. I think for this one, sometimes we actually need like traditional machine learning model, deep learning, NLP, and sometimes we also need like generative AI, LLM, reinforcement learning, but I think those kind of more advanced. And ML ops is also another piece that we need to pay more attention to as it becomes more and more popular. So essentially, ML ops try to take care of the end-to-end life cycle of machine learning models. And one popular open source library for this is MLflow. So I think in general, I think we all need programming, like in Python, R, or SQL. So yeah. So basically, yeah, I probably speak too much, but I think if we want to go into like different roles, I think that's part of my understanding.
I think those are great comments. I would definitely second everything that you just said there. But let me emphasize just a couple areas. I would say that for the business analyst, but also for the data engineer, really thinking about data quality assessment, when we're going to impute missing values, or when we're going to put something in. Well, what do we put in for when there's missing values, or do we have to handle those in different ways? For the business analyst, as well as everybody else, I think data visualization can be really invaluable. And it's not just for the business analyst. It's also, I think, for the data engineer and data quality work, because the data visualization can help identify problems in the data. So that can be very helpful there too. And then I like your point about domain knowledge. And I'd say 2 points there is like, don't hesitate to jump in and try to learn new things. Don't think it's outside of your job. That if you're working in a banking setting, you need to learn about banking. If you're working with blood banks or other healthcare things, you need to learn about, like, what do those healthcare codes mean? Or what different types of blood donations are possible, and how many days do you have to wait in between giving platelets versus giving whole blood versus other sorts of things. Learning the domain that you're working in is not outside your job. You have to do it. And by doing so, you learn to interpret the data, and how so much more of what you can and can't do with the data. So it's lean on other people who have been working in the field longer and try to learn from them, because it really is essential. And some examples of that would be that you learn not only what we were saying before about the missing values. Well, what is appropriate to put in as a missing value if someone is missing? Why is it missing? If a value is missing, is it missing because that person's maybe not eligible to open a bank account before a certain age? Or are they not eligible to donate blood if their weight is too low? Those are the sorts of things where then you might make different choices about missing values if you know more about the domain. Also, if you're trying to make data features, if you're doing feature engineering, which is something that I try to encourage people to do, don't just rely on exactly the data fields that you have, but also try combinations or ratios or other ways of transforming your data to make it more valuable. And so to do that, you often need to know something about the domain that you're working in. So I love domain knowledge. Now, again, I work across all sorts of industries, which means that when I'm working with banking clients, I need to try to learn as quick as I can about that, and then also to make friends with and rely heavily on team members who have that knowledge. But that's exciting, and don't veer away from it.
Yeah, I can support that last thought that Dr. Exer shared, because that domain knowledge is important when you speak with, and I happen to work with banking as well. When you speak with bankers in using their language, which they understand, they open up. Though they feel like there is subjects to discuss with you. You will understand them. You will know to solve them. How to solve their problems. If you don't speak their language, then you're in trouble. So, and that partially answers Elizabeth's question on chat channel, what new skills you had to learn recently. So one of them would be domain knowledge. Can you name any other, maybe Yong or Karl? Any other skills that you found useful and beneficial to learn recently?
Yeah, so I currently work in a lot of marketing related projects. I think, as I mentioned earlier, so I think one useful tool for data analyst is the related to causal impact analysis. So in marketing, whenever we have some marketing strategy, we want to measure whether they're effective, whether they can improve the business. So what we do is we basically try to do some geo experiment. So we split the U.S. region into two groups. So the one group without the new strategy, and the other one with the strategy. So then, in order to measure the uplift based on the new strategy, we need to do the geo experiment, and also we need to leverage some statistical analysis technique. So this is what Karl mentioned earlier. I think basically we want to use, in this case, we can't do A/B testing because we cannot make sure the two groups are identical. But then what we do is we kind of leverage causal impact analysis, which is based on some machine learning modeling to predict the counterfactual. So I think this causal impact analysis is I think it's one useful tool, and there are open source packages from Google and from Meta. So I think, yeah, if you are interested in that, that's something could be explored.
Yeah, and on my side, I'd say that, well, I consider myself very, very much a novice. I'd say explore the new generative AI tools and how they might be able to help you. And some of that can be helping you write code. And so, they're definitely exciting. They're definitely interesting. You definitely have to be careful in how you use them, but they're worth exploring.
Yeah, I think for that, I think we also we always use Google to find some search results, right? So with the Chat GPT, I think sometimes we can get better answer I think for that, I think if you want to get even better answer, maybe try to learn some technique for prompt engineering. I think those are like, we don't need modeling, but I think so it's just, some best practice for you to get a better answer with the large language model or ChatGPT in this case.
Yeah, I would also, one other thing I would add is don't shy away from learning a diverse set of skills, so that you want to know something about databases. You want to know something about cloud infrastructure. You want to know something about statistics. The field of data analytics, yes, you can really specialize down, but make sure you still have some broadness so that it helps you to interact with other team members who might be specialists in those different areas.
Yeah, so you brought up the generative AI, and this is definitely an elephant in the room. So we need to spend some, not just generative AI, it's one of the subject in that group of questions that I wanted us to discuss. So you say on one hand, it's very helpful and useful, so it can increase your productivity rate by helping you write code faster, probably better. And Yong mentioned, using ChatGPT and the like for finding quicker answers to some specific questions and so forth. But there is the other side of it, right? And since the audience is will be hitting the job market and sometime soon, some of the students are towards the graduation. So there are rumors that out there now that there will be no needed programmers anymore. A lot of code and not just code, and the methods will be generated. There is AutoML, right, that would run for you the search of various machine learning techniques and classifiers and whatnot. And data scientists will be no longer needed, or will be needed in smaller quantities, maybe data engineers instead, something like that. So what you can say about it?
Yeah, I can start. I think the short answer is no. I think we do have these tools like generative AI, AutoML, so they can automate a lot of tasks. Like feature engineering, maybe there are some like automatic feature engineering, data processing, model building. But I think they cannot handle a lot of problems that require like strong domain expertise and maybe very complex business problems. I think Karl just mentioned earlier that when we do the feature engineering, we actually require some domain knowledge. So if you know the domain better, you can come up with like better features instead of like the features that are very generic, from the automatic feature engineering process. So I think this tool can make our work lighter, I would say, if we use that in the right way. But I think we definitely still need human beings, to do a lot of work that the tool cannot handle very well. And yeah, I think, as I said, short answer is no, but I think this tool can actually help us and maybe change how the different analytics role function. That's my view on this.
Yeah, I'm also not worried about the AI taking over all our jobs, or just like the AutoML is a nice tool that enhances our ability to do more with data. It does not replace the need for data scientists or other types of data analytic roles. Some I have a couple examples of that. And so let's think about the automated data modeling tools that have been around for a few years. I've seen people try to use those to say, like, okay, we have a customer attrition problem. Okay, so how are we going to tackle the customer attrition problem? And well, they want to do a customer attrition analysis. So they take their data and they try to throw it into an automatic tool. Trouble is, they need to understand the techniques enough. They need to understand enough what data to provide to the tool and how to interpret what they get out of the tool. It's not doing everything automatically. And a lot of what doesn't get done automatically is the choices of data to feed in and how to interpret things that come out. Choices you make in the middle sometimes as well. So for example, in that I've seen a couple clients with this situation, and one wanted to take all the current customers and understand which ones are at risk of leaving. Okay, wanted to assign a risk score, so which ones were possibly likely to close their bank accounts. Well, they fed all the current customer data in. You can't, that's not going to help. For a customer attrition analysis, you have to have customers who are there, and you also have customers who close their accounts, so you can see what factors led up to the person closing the account. So if you only feed in data of your current customers, you're not going to be able to assign a risk score, and you're not going to be able to do the analysis to determine what factors are associated with people leaving. Alternatively, I had a different customer who had a similar sort of problem, and they fed into the data all the customers that left, and then wanted to know why they left. Well, they didn't include any of the current customers in the data set. So again, if you were trying to predict yes or no, does someone leave, you need to have both the people who stayed and the people who left in your data set that you put into these tools. So understanding what the tools are trying to accomplish, understanding what data to use, are essential for using the tools in the best way.
Yeah, I think it's a great kind of line of thought. So for me, in my mind, I imagine that as a sandwich. So you've got some business problem on the top, right, in the domain of your customers, and it's vague. It has nothing really to do yet with what we know how to solve using data analytics, right? Then we need some kind of conversion, some kind of mathematical interpretation of it, translation it into the terms that can be tackled by machinery of the data analytics. Then it will be handled there. And yes, the generative AI, the AutoML, and some other tools can help doing it faster potentially. But then results are obtained. Then you need to again translate that into the domain of the problem and present it to your customer. So those kind of two sides of the sandwich, they cannot be handled without a human. At least I cannot see that.
Right. And also, like Dr. Yong was saying, is how to apply that then, how to actually take your solution that you've developed and to deploy it. And do you deploy it in a way that allows you to do some sort of A/B testing to see if your solution is improving things or not? So again, those are all essential too. So that's not happening automatically. And the choices of what data to put in that's going to be related to the business problem doesn't happen automatically either.
So we've got just a handful, 4 minutes left. We wanted to leave 10 minutes for live Q&A session. We'll see how that goes. So I wanted one more question to squeeze in before that, and then we'll see that 10 minutes. If we don't have enough questions from the audience, we will continue with kind of our discussion. But one question before that. So since our student, some of them are still, in different stages of the program, but some of them think about graduation and what they're going to do next, right? And their options are right? As we saw in the chat, someone posted that, maybe to take a co-op, right, or internship, maybe get on the job market and start looking for a permanent position, or maybe continue with in the graduate school, because this is a bachelor program, right? So what's kind of your thinking, how would you, advise those students to proceed, just taking away financial situations and so far, so forth. Just purely the options are, co-ops versus job, starting to look right away versus continuing with the graduate.
Yeah, I think I can start. I think it depends on two factors. First, I think to me, in the last couple of years, the job market is not so good. So I think for that, it's maybe there are not a lot of jobs on the market, but I could be wrong. But I think, but this could change. I think maybe next year or maybe next 2 years. So the other factor is actually is about the students themselves, if they are eager to apply the knowledge and see some immediate result. So I think it's good, probably find a job. And if they want to do a little bit more academia or research, then you can like maybe pursue like higher degree, master or PhD. Yeah, that's my view on that.
Yeah, my thought is if you're exploring the job market, that you could explore both the market for jobs and co-ops at the same time. I think that co-ops and getting some experience while you're in your bachelor program, if possible, and I know Northeastern has definitely encouraged this years ago when I taught at Northeastern, I definitely valued that, and people came back from those co-op experiences and were much more grounded, I thought, and asked very different sorts of questions than the people who had stayed 100% in academia. So I definitely encourage people to get whatever sort of work experience you can through a co-op or by taking jobs. You can come back for a master's or PhD. I would encourage, even though this was not exactly my path, I took a break between my bachelor's and master's as well. But I would encourage people to work because I think that you will enter a master's or PhD program with a lot more perspective and focus on knowing what direction you want to go in if you've had some sort of experience working out in the real world. So whether that's a co-op or a job, so you could go straight through if you've had some co-op experiences along the way. But that would be my thing.
Yeah, I think to continue Karl's suggestion, I think if you start working, but you can still pursue advanced degree as a part-time manner, that also works. I see some people actually do that.
Lots of options, and it's a very individualized question of what works best and fits into a particular person's lifestyle and life situation, and all that too. But it's nice to see that there are many options. But if you can get real world experience working or in a co-op, definitely encourage that.
Yeah, that's great advice. So let's see if we have someone who would like to unmute and ask question in person. If not, we'll get going taking questions from the chat.
I would love to just share an observation. The first Mentorship Matters that focused in on healthcare administration is such stark contrast with data analytics. Analytics, your focus and your approach is so much more concrete and you're right to the point, and you guys are solution oriented and problem oriented, and you're getting right into the subject matter, which is kind of funny because our first Mentorship Matters focused much more on relationships. So one of the things that I'm observing and you guys are touching on is that discretion and context when dealing with big data really seems to matter. Being able to put it in perspective and develop good measures for like, what does this data mean? Karl, to your question about like leaving out customers who have left, only looking at customers who are still there. So when we think about those in-between spaces around data, the relationships, if this is such an individual contributor profession, people who are good with math, people who are good with programming, run good data sets, become good, I don't know if statistician is actually a word. How do you measure or encourage excellence in this field if it's such a person to their work, one-to-one relationship? Does that make sense?
Yeah, no, that's a great point. And I think that something we've left out that you start to highlight there is one needs to be able to communicate about data. And that can sometimes be doing data visualizations and doing technology things to show data, but you have to make choices there about what things you're showing and what things you're not showing. But you also need to be able, and I definitely encourage all of my team members in a consulting environment to develop communication skills, communication about data. And you need to be able to explain to other people why you did something, what the data means, how you're going to use it, as well as having those discussions that Dr. Shapiro was talking about up front about even when the project's starting, okay, there's the business problem. What data do we have that might be applicable to that business problem? To have the discussions with different domains, different data experts, different other people to say, what data could I even apply to this? And to have those discussions, one needs good communication skills. So I apologize for not mentioning communication skills earlier. They are essential.
Can that be taught? And did someone teach it to you? Or is that just a stylistic thing?
Well, I think it can be taught, but I think some people have skills in that area already, but it can definitely be developed. And encouraged, and I think that that's something that can happen in teams where you see people with good data skills, but you see people with good communication skills, and you then say, wow, okay. And you see the things that they do, and that's where maybe the mentorship or the working with a team really shines through. And it's not just a one-on-one, just one person working on something. You have to interact with other people about it, and you see other people who do it well, and you can learn from them. I don't think you can teach it so much as more you can see people who do it well and see some of the things that they do and go, oh, I need to do more of that.
Yeah, actually, we have a course that data visualization and communication or something like that. So we are trying to teach it, and there is a lot of that has been done in the field. So, but yeah, definitely communication. Explaining the outcome and the findings in understandable language is critical. Yong, do you have to add anything?
Yeah, I totally agree. I think when we work on some analytics problem, I think we actually have the problem from business, either from business team or from the executive team, and or maybe from customer. So to better communicate with these stakeholders, I think is a key to success. And to echo back to what you said, Vladimir, earlier, it is actually a loop, right? Like from business, we get the problem, get the data, then we come up with the technical solution. Then we need to go back to business. I think so. We provide solutions, insights. So I think we need to communicate with the business people in their language. I think communication is the key to success beyond the the technical skill.
Yeah. Thank you. So I think we all owe an answer to one of the questions on the chat, and that is about, so we mentioned that data analytics skills are kind of convertible, so you can work in many different industries. But if you, out of all options, you decided to continue with the master's, so would you suggest to stay in the data analytics or potentially consider moving to IT, computer science, maybe business, maybe some healthcare or other industry, assuming the other major, right? Assuming that you, you have inclination for it.
Yeah, I can start. I think depending on the interest, I think there are different roles as I mentioned earlier, like a data engineering part and data analyst and maybe data science. So I think if you are interested in machine learning modeling, I would suggest like take a major either in data science or just AI. And if you want to explore more on the data part, I think data engineering. So I think those should be part of data science major, but could also be part of the computer science. So I think that's my suggestion. Yeah.
Yeah, I see that it's nice to see now that there are many avenues that a person can pursue to be involved in serious ways in data analytics. And I think that you can choose the avenue that feels best to you, but definitely explore the different options that you might have. So something I'd add to that is if you're really interested in the sort of more the technical side of the computer processing part of it, maybe it's computer science. If you're interested in, and you want to apply your analytic skills in more of a marketing and business area, there are marketing analytics programs that focus not just on marketing in general, but analytics of marketing. So you might be able to do a concentration there, either in business schools or in marketing programs. If you want to be working in healthcare, there are places where you can get something where you're doing some parts of healthcare, but healthcare analytics. So think about what you want to do, and if you want to stay general, or if you already know that you are more interested in one part of it versus another part of it, then you can pursue a degree that is aligned to that.
All right. Thank you, Karl. Thank you, Yong. I think we are 1 o'clock. Arlene?
Yes, thank you all so much. This has been a fascinating conversation. Thank you. Special thank you to Dr. Shapiro for facilitating today's discussion. And Karl and Yong, I so appreciate you taking the time to share your expertise with the individuals on this call. I know I personally have learned a lot about the field of analytics and some of the important skills that are needed. And for those of you who are here today, each month we'll be featuring different topics. So in the near future, we're going to have biological science and biotechnology, digital communications and media that will be held in January. In February, we're going to have a Mentorship Matters on the topic of information technology. In March, project management, and then we'll be closing out our academic year in April on the field of psychology. So we hope to see you all then. But thank you all again for attending, and many thanks to our wonderful panelists. Have a great day.
Thank you.
Yep.
Bye-bye.
Hey, take care.